So hi, so I'll be talking today on Gitops and how we can use leverage Gitops with some of the tools that we are familiar with. So prior to going into the discussion, I'll just give you a brief introduction about myself. So this is Pavan. I have close to 2 decades of experience in DevOps, virtualization, and cloud computing. And that span of 2 decades, I have worked for different verticals and domains such as banking, fintech, life sciences, and healthcare for companies such as Danaher, Deloitte, IBM, so forth and so on. So yeah, that's about myself. And I'm founder at Prag-Matic. Uh, so we are a tech startup into services and AI product development. So with that, I will get into the presentation bit. So today's agenda is to give you an introduction on GitOps and also the tools that are part of the GitOps ecosystem. And then we'll finally get to a demo and all the code and the data would be shared to you through the references section. So to start with, um, so one of the questions that most people have is like, what is GitOps? So at the core, GitOps is like bringing the modern development practices such as DevOps and CI/CD part into the infrastructure management or the infrastructure uh, building of infrastructure. So, and the best part about GitOps is that you don't have to adopt or get into a new set of tools. At the very basic level, GitOps works with Git repos, so which everyone is familiar with. So, in case you already have a setup wherein you're running a CI system such as GitLab or Azure DevOps or something like that, you can just plug in GitOps into that, as we're going to see in the demo, and that's it. There is not much to it. And one of the uh, core principles of GitOps is being declarative. So what does it mean is in terms of GitOps, when we write infrastructure as code, we would like it to be in the form of either a language or a platform such as Terraform, wherein you write code, not code as per se, like Python or a Java, but you define this infrastructure configurations using YAML and Terraform or any of that IAC for that matter. And since it is all version controlled, so that's why it is well versioned and immutable. It has to be versioned and immutable. And another principle of GitOps is that there's something called pull-based deployments. So traditionally in software development, we are used to a push-based deployment. What I mean by that is the general workflow of your CI pipeline would be such that you will have a code repo in which you have your software development code, and then you have a CI pipeline which would be triggered based on either the developer check-in or a pull request or so forth and so on. So in that kind of system is known as a push-based deployment, wherein you just push in the code and then the pipeline triggers. But in GitOps, it is a bit different. So it is kind of like a pull-based deployment. So what I mean by that is, in GitOps, instead of these pipelines or this CI/CD tools, what GitOps consists of is software agents which go and sit in your infrastructure, and then they run this continuous reconciliation loops, wherein the agent will constantly check your infrastructure and the code, and it will look for any changes. If it finds any changes, it will go and implement that in your infrastructure. Now, one of the major advantages of with that kind of approach is in terms of security, at least, and which we're going to see in the next slide, is the security aspect. So in a typical CI/CD setup or in a DevOps setup, you have to give a lot of permissions to your build agents, which are running primarily in your CI tool such as GitLab or Azure DevOps or Jenkins. But in GitOps, you don't have to do that because these agents that run, all they need is access to the repo where you have stored your configuration files, such as the YAML definitions, in Kubernetes or your Terraform code. And apart from that, you need to give it access to the repo wherein it is going to store or pull this data from. So that's it. You don't have to give it a lot of extensive set of security. I would say a lot of access controls, like a lot of access which is not required. So it keeps things very simple. And since everything is managed in a Git repo, the error recovery is also pretty fast. So you can basically, if something fails, it's as simple as you go in and do a Git revert, and then you're sorted. You don't have to get into a very separate monitoring system or anything like that. You can just use the traditional Git tools to debug what's wrong, what has happened in that space. And another thing is the Gitops also it doesn't it's not only limited to Kubernetes. You can basically use your traditional configuration management tools and store your all you have to do is you have to store your code or that configuration in a Git repo, and that's all. So this talk is primarily on Flux and some of the other tools, but this can be achieved using even your traditional infrastructure configuration management tools as well. So next we are going to look into the tools side of things, which are the tools which we are going to use in today's demo. So one of the tools that we are going to use is Terraform, which I think a lot of people here would be familiar with. So Terraform, if not, Terraform is basically an infrastructure management tool, which allows you to define infrastructure configuration in a simple HCL or their own proprietary HCL language, wherein you define the infrastructure and then you store it either in Git or your local system. And then you just run the Terraform system to just plan and see what happens if the code will run. So it's kind of like a staging environment, just like in Git. So before you actually do anything, you can just do a Terraform plan and it will show you what exactly it's going to build. And then, of course, if you're satisfied with everything, then you can just go ahead and do a Terraform apply, and then it will basically provision your infrastructure. And so GitLab is one of the CI systems which is quite similar to Jenkins or Azure DevOps or any of the AWS CI/CD tools that we have in the market. But GitLab offers a lot more than just CI/CD capabilities. It also has a lot of security and compliance aspects to it, wherein you can do code scanning to find out any vulnerabilities. And apart from that, it also helps you to store your packages. It can be either a Docker container to a Java jar files or anything that you can think of. So next up is Flux. So Flux is one of the tools which is part of the GitOps ecosystem. Now, primarily, there are two main features of Flux. It follows the GitOps-based deployment, meaning Flux usually works with Kubernetes, so it goes and sits in your Kubernetes cluster and starts looking for events that require for it to trigger any changes in the infrastructure. So for example, let's say you have created a cluster with 100 pods of your application running. Now let's say you go ahead and make the changes to it and just commit to the Git repo. So what Flux will do is it will notice that change and it will reconcile and go back and make the changes automatically to the Kubernetes environment without you doing anything about it. So that leads to a very fast deployment, I would say very fast deployment rates as compared to traditional, I would say CI/CD kind of a solution. Or if you're running a typical IAC kind of a model wherein you're just triggering everything through your local system, or you're keeping it in a remote backend or something like that. And another advantage, as I was talking about the automated synchronization part, which I was just referring to, so that also plays in a key role in Flux managing these components. So there are a lot of capabilities, interesting capabilities that Flux has got. So I'm just going to go through some of them. So one is obviously the GitOps and the automation aspect. And another interesting aspect of Flux is that it also can trigger alerts. So let's say you have a communication software such as Teams or Slack. So you can integrate Flux with uh, those kind of tools, and every time you deploy, Flux will send you a notification. So you can basically create maybe a dedicated notification channel wherein you can add the respective members who would be taking care of that, and then you can get those notifications delivered to you as Flux or any changes that are made. So in that case, in that way, you have the visibility as well. Now, one of the things is with Flux is it's an open source tool. So a lot of folks have comprehension, especially in the enterprise segment, that if it's open source, how good the support is, and what if something goes wrong. So I've been using Flux for I think almost around 4 years or so, and so far what I've seen is the community behind Flux, the developers, they're pretty good. So you get responses quite quickly for any issues that you face. So you can go ahead and test it in your environment, and you can easily implement that in the production environments as well. Now, another aspect of Flux is it's integrated with known monitoring tools such as Prometheus, Grafana, and that's where the monitoring of Flux comes in. So you can easily monitor Flux either through Prometheus and Grafana as well. So you don't have to install or configure any specific monitoring tools which only cater to Flux or something like that. So, and obviously Flux is pretty well integrated with Kubernetes. As of now, Flux can also manage Terraform resources, but more on that in a bit later. So next up, this is the overview on some of the components inside the Flux. So as you can see, there is something called controllers in Flux. So there are primarily 5 of them. Now there have been many more controllers that have come up recently, but these are the core components of Flux. The first one being the source controller. So if you remember, I was talking about the access part of the Flux, wherein you don't have to give it a lot of access. So one of the things that Flux requires is it requires access to your container registry in case if you are your image or your artifact is a container, and then it requires access to your source control. So this source controller, it keeps a tab on those repos, and it checks for any changes. The moment it detects any changes, let's say you have pushed a new code or you have pushed a new image onto your onto your Docker container, so this is the controller that's going to take a look at it and notify other controllers. And then you have got customize, which basically helps. So once the source controller gets all the artifacts and everything, what customize controller will do is it will take those artifacts and then apply it to your Kubernetes cluster. Now, similarly, we have Helm controller, which takes care of Helm charts. And then the notification part, which I was just discussing. So the notification controller takes care of that aspect. Now, the last bit is the image reflection and automation controller. So there are these two set of controllers are the ones which manage these container images. So when you push something into a Docker registry like an ECR or an Azure container registry, so these two controllers, what they do is they will take that image tag and then they will apply it to your YAML file, which is stored in the Git repo. So this is basically this talks about the overview of all the controllers, which I was just describing. And this is a typical workflow of Flux, wherein, as we can see, whenever we push a code change um, into the repo, Flux will notice that change and it'll go ahead and apply to the Kubernetes. So I'll move quickly over to the demo side. So for this demo, I have recorded a video. It will not be like a live demo. So I'll just play the video. Okay. So first we're going to generate the token. So one of the things that we have to do is we have to give it access to one of these. Um, yeah, so access to one of the repos. So that's why we are going to choose just the API from this list of access controls. That should be enough for us to, for Flux to do the changes and reconcile. And then we're going to keep the copy the token, which we're going to use it at a later stage. Next, we're going to do project creation in GitLab. Here, we're going to provide a name, and then you can choose either the project to be public or private. It depends on your preference. And then we have to select a group. So this group is something that we are going to again utilize at a later section, which I'm going to show. And that's it. So in this section, we're going to do the setup in our CLI. So the token that we copied earlier, we just have to come back and export the token. And the name of the variable, it has to be like GitLab underscore token. So this is something that is required when we do the Flux configuration for it to authenticate to the GitLab repo. So once we are done with that, also what we can do is if you don't want to like every time export it, you can just add this command to your bash RC or a ZSH file so that you don't have to export it every time. Now, what we're going to do is we're going to clone the repo which has got the Terraform files and the configuration files. Now we're going to delve into what is there in the repo. Okay, so I'll just zoom in a bit in the code so that you can see. So this is pretty standard Terraform modules. First, we are, as you can see in the code, we are trying to build a VPC and an ECR repo where we will store our container image. And here, generally speaking, as of today, the ECR in general, we used to have the scan on push, which we used to by default enable. But as of today, we can actually configure this particular setting using the ECR registry scanning configuration. So here we're just, this setting, what it does is every time you push a new image to ECR, it will scan that particular image for any vulnerability based on the database that AWS has got. And then we are basically configuring the EKS cluster. So nothing too exorbitant here. So here we are just defining some of the plugins and the add-ons which we want to install in the EKS cluster. And then there are some node groups that we are defining. So if you can see here, for the demo purposes, I have put the capacity type as spot for a EKS node group. Now this can be on demand or a mix of that. But generally speaking, spot instances are like AWS has got the reserved, not the reserved, but a spare instances, whichever AWS has got, just to save the costs when we utilize them. So those are the kind of instances which are called spot. But one thing you have to realize is if you are using this for just for testing purposes, it's absolutely fine. But spot instances, though they are a great add-on to, to reduce your cost in the cloud, but they do get taken away from AWS with the 2 minutes of notification. So in case if you are testing it in your test environment, it's absolutely fine. But if in case if you want to do it in a development environment or a little bit more advanced environments, you have to do a mix of on-demand and spot. And you obviously would need some kind of cluster autoscaler, which will manage that interruptions which spot instances cause. So next here, we are providing the access of the cluster to a specific principal ARN, which is basically like it can be an IAM user, or if it is a SSO, if it's an SSO setup that you've got, the SSO user role that you can put here. And then if you see the policy association, we're providing it the cluster admin and EKS admin policy, which will basically give it complete access to EKS cluster. And then here, what we are doing is, so usually what I have seen is when we use Terraform to spin up EKS clusters or any Kubernetes resources, sometimes at the end of it, when the resource is configured, sometimes you get these errors where Terraform is not able to communicate with EKS cluster. So just to avoid that, we have added a local exec provisioner, which basically runs this command, which will update your local kubeconfig file with the EKS cluster that you're building. So in that way, your entire deployment goes through smoothly, and you don't have to again stop and rerun the deployment and reconfigure this. So this one step will help you in doing that. And then there are a few of these resources, such as the private key, which would be used by Flux to authenticate with GitLab. And here are some of the variables. So if you remember, I was talking about that GitLab group. When I was creating the GitLab project, I had copied the GitLab group. So that is where that value will go in here, and the project which you just created, the name of that project. So once you have that, then we'll move on to the versions. This is basically your provider configuration. So if you see here, we are having providers such as Flux, GitLab, AWS, and Kubernetes. And in the bottom, we are just configuring those provisioners uh, with the host name, which basically would be picked up by the EKS module which we have written. Okay, so this is the application configuration. It's pretty basic Go web app, which you would be deploying to ECR. Okay, now moving on to the configuration files. So one of the challenges with ECR or repos such as that is their authentication tokens are constantly rotated. So this particular configuration file, what it will do is it will create a cron job in your EKS cluster, which will basically do the authentication for Flux, and it will provide the token or hand over the token back to the Flux controllers. So that image automation controller, which I was talking about, so it will hand over the token so that it can authenticate and pull the images from ECR and update your Flux configurations. So this is that particular file. And this is the cron job I was referring to. So usually when you spin up the cluster, immediately the Flux components are going to query those image repositories that you have configured. So that's the reason I put the schedule here as 1 minute. Usually this should be 6 hours, because the ECR tokens get expired every 12 hours. So we have ample amount of time to run this cron job. But just so that after you deploy your the Terraform bits, it should not be the case that you get errors in Kubernetes that the image is not the image controller is not able to pull the image because of the authentication issue. So that's why the schedule is kept for 1 minute. And this is the app configuration. So here, the first thing is we have defined a secret, which is basically that PAT token which we had generated in GitLab. So what you have to do is you have to basically base64 encode it. So it's pretty simple to do a base64 encoding of a string, and then put it here. And apart from that, now we'll move to this Flux components which we require for our application. So one of those is the Git repository, which I was referring to, that Flux will require access to two types of repositories. So this is one of them. So it's basically the Git repo of the files that Flux will store, the deployment.yaml files that you saw, and even the Flux configuration. So this authentication, it basically enables Flux to store that data automatically when it actually runs. And then we have this customization bit, wherein we are telling it that in this path, the /apps is where it needs to look for the Kubernetes YAML files, which it is going to go ahead and apply it to the EKS cluster. And then we have the image repository. So this is nothing but the Docker registry. So this URL is your ECR registry URL, which you're going to provide here. And if you see here, the secret reference, it's talk about the ECR credentials. So if we go back to this cron job, yeah. So this cron job basically creates that credentials every 6 hours. So that's how this is going to authenticate. So now what we are going to do is we're just going to, since we have cloned the repo, we're just going to run the Terraform init and the plan part. So that should spin up our infrastructure. So I'll quickly go past this. Okay. So we basically have created all the resources that we just discussed. So what happens is after this completion, the project that we had created in GitLab, what Flux will do is it will create these additional components, which is under the folder of Flux system. So there are basically three. So there are basically three components, which is sync, customization, and components.yaml. So I have linked this to in the references section. You can go through this in detail, but I'll just give you an overview of this. So this first bit, the GOTK components.yaml, it is these are all the various components that Flux. These are various Gitops components which Flux will create. So that is this file. And then the sync is basically the synchronization part, which I was talking about. So Flux has to synchronize with the Git repo. So this particular file will configure that. Yeah. Okay. So I'll just walk through the application, the code part, real quick. So this is a 1 minute. So this is a basic Go app, which will just run a web app at the port 8080. And this is the GitLab CI pipeline. So it basically it will authenticate with AWS ECR and then upload the image to the ECR. And these are some of the variables that you have to set for the pipeline to run. One is the region in which you are obviously going to spin up the resources, and then your AWS profile and the repo URL. And the role ARN part is something that the role that which GitLab would be using to authenticate via AWS. Okay. So now that we have spun up all the resources, now we'll just go ahead and check whether all the resources are up and running. Okay. So as you can see here, we have just run this command, which which basically will list out all the pods in the Flux system. So these pods are the various components of Flux, such as Helm controller, image automation controller, and so forth and so on. Yeah. And then we are listing, then we are issuing this command, which basically will list all the image automation controller bits of Flux. So this is the image repository, which is there in AWS. As you can see, it was able to scan the image successfully, and it found 3 tags. Then is the image policy. So image policy, basically, it will tell Flux how to update the YAML file, and we're going to look at that. Yeah. And so this, if it is like, if you get any errors here, that would mean that the authentication to the ECR is not happening properly. But since we have configured the cron job to run in a minute space, as you can see here, it already has completed. So that's why we are getting this, we are able to scan those tags. Okay, so now what we're going to do is we're going to change the application bits so that we can see what Flux will do when it detects those changes. So this is how the application looks right now. It's basically the hello world display page. So what we are trying to do here is we are trying to just change the color of that particular header. Once we do that, then the pipeline gets triggered. And this will basically create that Docker image, and then it will push to ECR. Okay. Okay, so now what we are going to do is, our application is running in the default namespace. So we're just going to watch what happens when these changes take into effect. So the -w is basically a watch command. And the moment we run it, we see that the old pod is running since 9 minutes. And now you can see that we have a new container that is coming up. So this is basically Flux detecting the change in the ECR and then making those changes in the Kubernetes cluster. And you can see here that the color has changed from blue to green. Okay, so if we go back to our repo where we had those components stored, you can see here these messages, which basically tell that, so this is authored by Flux. It basically took that, it detected that there was a new image that was pushed, and then it added these configurations. So it actually adds this configuration in this particular file, our deployment file, where we have the image definition. I'll just zoom in into this bit so that you can see. Okay. So as you can see here, Flux has made the change to this particular definition of image, and the way it does it is through this particular snippet here. So that basically is image policy. So this first bit is the namespace name, and this is the image policy, which we had defined in one of the earlier configurations. Okay, so what you saw was basically Flux, how it manages Kubernetes components and all. But I was talking about the monitoring aspect of it, right? So we definitely can use Prometheus and Grafana, but there is one tool which is called Capacitor, which basically helps you monitor the Flux resources. So it's also an open source project. So here, um, so I have included these configuration files in the repo, so you can basically look at them, download and use them. So that once we apply that configuration file, this is how the application looks like. So this gives you a lot of information about what has been installed, what kind of pods are running, uh, and you can actually see the logs of each of these components, such as the image controller, and even you can see the logs of your pod or application, which have been deployed. And you can even ask Flux to do a reconciliation through this particular portal. You can just click the button. It'll go and check for any changes manually. And you can see the logs of the various components by just clicking on the log button. That's about it. Thank you for your time.